Good day. I'm happy to welcome everyone to the fifth and final lesson of the 3D modeling course on the nanoCAD platform. Today, we'll cover important topics like using 3D arrays and creating assemblies from individual parts to better understand the material and practice modeling skills. I recommend following along with the steps I'm demonstrating. Don't hesitate to pause if you need more time. The array creation operation is the process of copying a 3D object and making copies in either a rectangular or circular pattern. Let's explore the process of creating an array with an open part as an example. Why might we need to use this command? Let's say we need to create many identical slots in this plate, arranged in a specific pattern. We can achieve this by creating a complex sketch or by using the array tools when creating a sketch. Or, we can use the 3D array function on the 3D Tools tab. Let's choose the 3D rectangular array function. Select the slot as the element. Specify the first direction of the array. To do this, click the Direction button. This can be the edge of a 3D object or a standard or custom axis, which we can create using the Work Axis command. In this case, we'll select the edge of our part. After choosing the direction, the future array's phantoms will appear. In the Operation menu, we can change the direction of the array, its number of elements, and the distance between them. For example, let's set the quantity to 5 and reduce the spacing between elements, say, to 30. At the bottom of the window, we can change the way the array is created by switching between step and range. If we choose range, the number of elements we enter will be evenly distributed within the selected range. If we need exactly 5 slots on our plate with equal spacing between them, we specify the dimensions of our sheet minus the spacing to the edge, and the program will automatically adjust the layout of the slots. Since our sheet is 390 millimeters long, with a 10 millimeter space from the edge to the first slot, we can specify a range of 330. Thus evenly distributing the elements across the sheet. Similarly, we can specify a second direction for the array distribution. Change the array's direction. Specify the quantity, say 6, and set the range to 200. Finish the command by pressing OK. To demonstrate the array creation functionality for 3D bodies, we'll reactivate the rectangular array command, but this time we'll choose a body array instead of an element array. Select the plate as the element. Specify the direction, for example, choose the Z-axis, and then set the quantity and step or range. Let's reduce the quantity to 3, for instance. Click OK, and we get a 3D body array where the original body is separate, while the array elements form a different body. Let's deactivate the rectangular arrays and move on to the polar array. The difference from the rectangular array is that the elements are copied not along a selected line, but around a specified axis. For instance, let's create a sphere using direct modeling. Activate the command. Choose the element to copy and the rotation axis. It could be a face of body or a standard or custom axis. In this case, let's use a standard axis. For instance, choose the Y-axis. Below, specify the required number of elements. Set it to 6 and the angle. In the Angle Selection option, we can specify the filling angle, and the chosen number of elements will be arranged in the specified range, say to 170 degrees. Or we can choose spacing angle. For instance, let's keep 3 bodies and set the angle step to 120 degrees. As we can see, we've created an array of 3D bodies around the Y-axis, and the angle step between them is 120 degrees. The final array function is 3D mirror. It can be useful if we don't need many copies, but want to mirror an element or body relative to some plane. Deactivate the 3D array and reveal our plate. Click the 3D Mirror command and choose whether to mirror elements or bodies. Select array of bodies and the reflection plane, such as ZX. Finish the command by pressing OK. As we can see, a new body has been added to the 3D history. If we expand it, we see that it was created with the mirror command. If we change the initial version, the entire array will also change. For instance, let's change the extrusion and set it the join option instead of cut option. Click OK. We can see that both the original body and the arrays, created either as element arrays or 3D body arrays, have changed. And our last mirror command has also been updated. This concludes the first part of the 5th lesson, focusing on array commands. Feel free to practice with array commands on your own if you'd like. When you're ready, proceed to the next lesson part.